Okay, so we're continuing on with the question, part two of the question that we previously done. Remember, guys, this question had a lot of different theorems. It was a combination of a lot of different theorems, a lot of different rules that we've learned previously throughout the year in Euclidean geometry. So this question is really good. It is really good to test, to effectively test your knowledge on Euclidean, to actually test your skills on the entire topic in general, right? So you cannot be intimidated with the questions that have a lot going on, with the questions that have a lot of different theorems that have to be applied to the question. You guys test yourself to see how good you are and how much you've improved in Euclidean. But other than that, guys, let's get started. So let's look at question 9.2.3. They tell us that we have to write down with reasons the value of AF to FE. Right, AF to FE. So AF to FE. Let's pay attention to the triangle that it is a part of. AF and FE are a part of triangle EAD. EAD. Now, just like I said previously, guys, AED is a triangle with two parallel lines. Those parallel lines divide that triangle proportion, meaning that the sides of the triangle are all in proportion to one another. Now, what rules do we actually use when we want to explain this or validate our reasons? You can just go back and state the prop theorem, or you could also say line parallel to one side of triangle. Okay. So now, guys, if you want to calculate AF to FE, that's pretty simple. AF to FE, AF to FE is in proportion to AH to HD because of the prop theorem, or you could say line parallel to one side of triangle. So all you have to do is you have to just say AF over FE equals to AH over HD. And we already know what HD's value is. By the way, guys, this is not its value. This is its ratio. That's why I've put a little constant. That's why I just put a little variable over there just to indicate the fact that it is not its actual length. It is just its ratio. Okay. So now what you're going to do is you're just going to go back and write down but you have to let the marker know, okay? Let AH equal to 5A and let HD equal to 7A. Just like I said previously, remember, guys, AF over FE equals to AH over HD. And we already know that AH over HD equals to 5A over 7A because that's what they've given us in the segment. Above, the a's cancel out, leaving us with 5 over 7. And your reason is prop theorem. But if you're going to use the prop theorem as a way to validate your answer, you have to state the lines that are parallel to each other, which actually allows us to use the prop theorem, okay? So if you go back, guys, which lines were parallel to each other? The lines that were parallel to each other was FH2 and ED. FH is parallel to ED, and that's exactly why the prop theorem was valid, okay? You can also just say line parallel to one side of triangle. If you use y line parallel to one side of the triangle, you do not need to state the lines that were parallel to each other. Okay, and that's exactly how easy it is. And after you're done with that, what you want to do is you just want to go back to your diagram. You just want to go back and annotate that onto our diagram. So now we know that AF was 5. We're just going to label it as 5A as well because this is not its actual value, guys. This is its ratio, 5A. And then we also found out that FE is 7A as well. Okay, just want to go back and annotate that. Now let's continue on. 7.2.4, determine the area of triangle AFH over triangle AED. Now, this question actually comes up every now and again, and a lot of people are just taken aback when they see this question because they don't practice it often. And that's exactly what I'm here to do, guys. I'm here to literally prepare you for any questions that they might throw at you. But this question, don't get me wrong, it is kind of a question that comes up pretty often. So, this is exactly what you're going to do. First and foremost, we have to identify the triangles. Let's just go back and see where these triangles are. Okay, so triangle AFH would be this triangle over here. Okay, and then the other triangle would be AED. AED would be the larger triangle. Now just look at what's happening, guys. These triangles share the same vertex. The vertex would just be the point at which the triangle ends. This part of here, this is the vertex. So this is triangle AED, and this is triangle AFH. They share the exact same vertex. If they share the exact same vertex, guys, and you need to calculate the area of both of the triangles, but that is position, you can obviously see that it's in a form of a fraction. Use this exact same method that I'm going to show you. You have to use this formula. So, what formula were you going to be using? You're going to go back and write the formula of the area of triangle AFH equals to the area of AED. It equals to half of the length of AF and HAH. Okay, but let me show you exactly how this works, right? So now we've identified where these two triangles are. We know that they both have a common vertex. They share the exact same angle, which is A3. Okay, so we definitely know we're going to use sine as our way to calculate the area of these triangles in a fraction form. The next thing that you need to do is you're going to you're going to say a half. Let's start off with triangle AFH. A half multiplied by one side of the triangle that leads to the vertex. So one side of the triangle that is literally right next to the vertex, that is right next to A3, would be AF. And then you're also going to take the other side that is right next to the vertex, next to A3, which is AH. And then the last part of it is you're going to say multiplied by sine A3. The reason why we're picking A3 because A3 is the vertex that both triangles have in common, right? A3, and that's literally just how the formula works. Okay, and that is for AFH. Then for AED, it's the same thing, guys. You're gonna say a half multiplied by the one side of the triangle that leads to the vertex. It would be EAE. So you're going to multiply that with AE. It's the exact same thing. Multiply AE with AD, and then you're going to multiply AD with sine A3 as well because they share the exact same vertex. And that's exactly how we got to this part on the memo, right? It's exactly how you get to there. Now, the next thing that we have to do is we have to substitute the value of AF. Okay, so now guys, what is the value of AF? Let's just go back and look. So AF's value is 5A, guys. Remember, we've marked it off as being equal to 5A. So we're just going to label this as a half multiplied by 5A. And what is AH's value, guys? AH's value is also 5A. So you're just going to label that as 5A. Okay? And then we still have our sine. We still have our sine A3. Okay? And then for the next part, you're going to do the exact same thing. A half, what is AE's value? AE's value is, by the way, guys, we're looking at the entire length, AE. AE's value is the 7A plus the 5A, which gives us 12A. So we're left with 12A. What about AD? It's the same thing. The entire length of AD is equal to 7A plus 5A, which is 12A, multiplied by sine A3. Okay, so by the way, guys, we can cancel out the sine A3s cancel out. This is something you can do if you literally just have like multiplication signs between each and every single variable in your expression. In your fraction, you can just cancel out the sine A3, and then the halves also cancel out because they're literally identical. Okay, then 5A multiplied by 5A is going to be 25A to the power of 2. Okay, and then 12A multiplied by 12A is going to give us an answer of 144 A to the power of 2. And what happens is the A's cancel out, leaving us with just 25 over 100. Now that's a very, very effective way of answering these type of questions. Super duper easy. So that's how we got our answer of 25 over 144. Let's continue on with the next question. Gonna continue on with 9.2.5. Calculate the length of OH. Okay, so the length of OH. OH is this small part over here. Now, a lot of students just don't know where to begin. They don't know where to start. That's what a lot of students struggle with. We're looking at OH, this part over here. Now, this is a little trick and a little hack I want you guys to remember. If you need to calculate a part of a line that isn't like a radius, a part of a line that is a part of a bigger line that already has values, then you need to formulate an equation for yourself. So what do I mean by this? Look at OH. OH isn't a radius, but OH is a part of a bigger line that actually has a value. OH is a part of, for instance, OB. Okay, OH is literally also a part of OC. We already know what OC's value is. Remember, guys, OC is a radius, and we've already calculated what the radius is back in 9.2.2. We said that the radius is 15 over 4. Okay, so what does that mean? We know that OC is 15 over 4. So we can just use this to our advantage, guys. You need to formulate an equation for yourself if you're trying to calculate a part of a line, and that isn't exactly a radius, right? So that's the very first thing we want to do. So what we're going to do is we're going to let OH equal to X, but you need to let the marker know, obviously. You need to let the marker know that you want to make OH equal to X, right? Then the next thing that you want to do is, okay, we know that OH is a part of OC. Okay, so you're going to just quickly write down OC. OC equals to X, which is OH, okay, plus HC. Okay, what is OC's value again? Remember, guys, OC is our radius, and we already calculated back in the previous question that the radius was 15 over 4. So you're just going to go back and write down 15 over 4. We don't know what X is, so we're just going to leave it as that. And then we have HC. But still, guys, how are we going to calculate what OH is? Remember, OH has, X is representative of OH. This is what OH represents. It's the extra value. Now, let's look at HC. Can we somehow find out what HC is equal to so that we can get to X? Let's look at the triangles that HC is a part of. You need to pay very close attention to this, guys. HC is a part of triangle ECA. And the best part about this is we actually have parallel lines. Okay? We know that we have FH. That is, by the way, guys, they told us that FH is parallel to TAB, but FH will also be parallel to AB because AB forms a part of the longer line. That's so important to remember that a lot of students don't realize. If you have a line that's parallel to a longer line, that line will also be a part parallel to the different parts of that line. So in this case, FH is parallel to TAB, but FH will also be parallel to AB. So we're just going to mark that off, right? So we can clearly see that the prop theorem can be applied. Remember what I spoke about? Prop theorem, you have two lines that are parallel to each other, and they divide that triangle in proportion, meaning we can use our prop theorem, meaning that the sides of that triangle are in proportion to one another, okay? So we can easily just, make HC the subject of the equation, and then we're going to use our prop theorem to calculate what HC is, okay? So this is exactly what they did over here, guys. The HC was then equal to 15 over 4 minus x, okay? So you just get to that value when you take the x over onto the other side, then you're going to be left with 15 over 4 minus x, okay? That's how we got to this part over here. So now that we know that HC is equal to this value, right? Now that we know that HC is equal to 15 over 4 minus x, now what do we do? Remember, guys, pay attention to the yellow triangle. And we first want to identify which sides are actually in proportion to one another. We know that EF over FA will be in proportion to HC over EH. Okay, we know the value of EF, we know the value of FA. Okay, we know the value of HC, but we don't know the value of EH. So we also need to formulate a little equation for EH as well before continuing on, okay? So now let's pay attention to what EH actually is. EH is not a radius, guys, but EH has a radius that is a part of it. Remember, EH is made up of OH, and we've already labeled OH as X, and it's also made up of the radius, which is EO. Okay, so we're just going to quickly go back and write down. We're going to go back and write down and say EH equals to EO, which is a radius, and that's 15. That's 15 over 4. And it's also a part, and it also forms a part of, and OH is also a part of it, and we've labeled OH as X. Okay, so make sure you just pay very, very close attention. Let me just highlight it so you guys can see. Carefully. So this is EH. It's made up of X and 15 over 4. So we've already drawn up a little equation for ourselves. Okay, so now it's perfect, guys. We know what EF is, it's 7A. We know what FA, it's 5A. We know what AH is, it's 5. Not AH, sorry. We know what HC is, it's 15 over, we know it's 15 over 4 minus X. And we also know what EH is. EH is 15 over 4 plus x. So now we can just write down the ratios of EF over FA equals to HC over EH. Okay? And the reason for this is prop theorem, but you have to state the lines that are parallel to each other. AF over FE equals to, they've made a little error over here, by the way, guys. This is supposed to be HC, not HE. BH over HC, we know that 5AF was 5A, but obviously the A's cancel out. It was 5A over 7A, but the A's cancel out. We've already calculated the fact that BH is equal to 15 over 4 minus X, and we know that HC was 15 over 4 plus X, okay? So what you want to do is you want to cross multiply, but be very, very careful, guys. Once you cross multiply, okay, so what you want to do is you want to cross multiply. So once you cross multiply, you're going to be multiplying the 7 with the 15 over 4 minus x. And once you do that, guys, just remember to include it in brackets and leave that number outside of it. The 15 will be multiplied by the 15 over 4 plus x. Make sure you also leave it outside of brackets. Then you start foiling the number in brackets. 5 multiplied by 15 over 4 is 75 over 4. 5 multiplied by x is 5x. 7 multiplied by 15 over 4 is 104 over 4, 105 over 4. 7 multiplied by negative x is negative 7x. So what you want to do is next, you want to take the 105 over onto your left-hand side, okay? So once you take it over onto your left-hand side, it's going to become negative. Then you're going to take your 5x over onto the other side, onto the right-hand side. It's also going to become negative. 75 over 4 minus 105 over 4 gives you an answer of negative 15 over 2. And then negative 7x minus 5x gives us an answer of negative 12x. What you want to do is next is you just want to cross multiply. Negative 12x multiplied by 2x is negative 24x. You're going to take the 15 over onto the other side. You're still going to have negative 15 on the side. Then what you're going to do is you're going to take the 24, negative 24, divided by the negative 15. That's going to give you an answer of 5 over 8 meters. And that's exactly how you'd get to your answer. Okay, so we've come to the end of the video. Hopefully this video was helpful, guys. If you want the PDF version so that you can print it out and start practicing on your own, or if you just like the PDF, please make sure to email me. And also, guys, if you really need help, if you really want to start going over the commonly asked exam questions to ensure you are 1000% prepared for your final exams, make sure you send me an email so we can join the sessions that I host where we go over the most commonly asked exam questions for both math and physics. But other than that, I will see you in the next video.